Bismillahirrahmanirrahim. Hello everybody. This is an exercise, the third one of the midterm exam, National High School of Mathematics, Algiers. So solve the equation, the integer part of x equal to 5. X is a real number. Actually, we have at least three methods. I will try to give you two methods. First of all, and before to start, we can immediately remark that this equation implies that x, the integer part of x, is strictly less than 6 and greater or equal to 5 immediately. First method, this one is the basic one. We will distinguish two cases: x less than 0 and x greater than 0. X equal to 0, there is no solution, it is obvious. So with the first method, we consider that x is strictly less than 0. If x is strictly less than 0, we know that for all x in actually in R, we know that the integer part of x is less or equal to x, but it is strictly greater than x minus 1. We take this double inequality and we start by x less than 0. So if we times the both inequality of x minus 1 less than the integer part of x less than or equal to x, we will get x squared less than or equal x, the integer part of x, which is less than x times x minus 1. This is the first inequality. The second inequality that we had from the basic equation is this one. We have x, the integer part of x, is less than 6 and greater or equal to 5. And here we can remark that, for example, we can remark that x times x minus 1 is greater than 5 and x square is strictly less than 6. We can use both of them to solve an double inequality, and we get a common interval. This is a method. I will use it in the second method, but right now we can just use one inequality and discuss cases. So from this in double inequalities system, we have x squared less than x. This implies that x belongs to minus square root of x. Actually, the square root of x, minus the square root of 6, the square root of 6. But since we suppose first that x is less than 0, we can just reduce this interval to this one. But to remark that minus square root of 6, 0, is equal, we will divide it to minus square root of 6 minus 2 union minus 2 minus 1 union minus 1 0. Then we take for every single subinterval discussion. We will have a discussion. If x belongs to minus square root of 6 minus 2, from this we can deduce that the integer part of x is equal to minus 3, and x is between minus the square root of 6 and minus 2. If we take x from this interval and we times it by minus 3, the last value that we can obtain is minus 2 minus 3, which is equal to 6. And since it is equal to 6, this means that it has no solution. It is strictly this. So I can do it. So x, integer part of x, is strictly greater than plus 6. So we cannot solve this equation. The second case, if x belongs to minus 2 minus 1, then the integer part of x is equal to minus 2. And in this case, x, integer part of x, is strictly is less than or equal 4. So there is no solution. If x belongs to minus 1 0, then the integer part of x is equal to minus 1, and in this case x, the integer part of x, is strictly less than or equal to 1. So there is no solution. We have no solution. So in the case 1x is strictly less than 0, we have no solution. Suppose that x is greater than 0. In this case, we will suppose that x is strictly greater than 0. This equation, we will be keep it as its state, but the second one, the first one will take this form. Here x square, and here x minus 1. X times x minus 1. Okay. We can use this double inequality to get what? In this case, we can just use, for example, this one. We can use them both and solve a system of inequalities, but just one, it's largely sufficient. From this, we deduce that x times x minus 1 is less than 6. This is less than 6. If we solve this double inequality, we will deduce that x belongs to 3, which means that the integer part of x is equal to 2. If the integer part of x belongs to 2, we have this double inequality, which implies that x is less than 6 over 2, which is equal to 3, and greater than or equal to 5 over 2. Actually, this is a unique interval of solution. So solutions of this equation are all x from 5 over 2, 3. This is the first method. Second method, for the second method, suppose that there exists n from z such that x is equal to n plus r, and r is strictly less than 1 and greater or equal to 1. Once again, we discuss two cases. First case, when x is negative. In this case, n is negative. It is actually negative. Okay. From the equation x, if we use this notation, we will get this, which is equal to 5. And from this, we get that n plus r times n is strictly less than 6 and greater or equal to 5. This is the first important inequality. The second important inequality is actually, we know that r belongs to 0, 1, half open interval. If we add n, we get n plus r less than n plus 1 and greater or equal to n. This is the second important inequality. In the first case, when we suppose that n is negative, if we times by n, we get that n times n plus r is less than or equal to n squared, and strictly greater than n times n plus 1, because n is negative. This is 1. And the second inequality is this one. We have n times n plus r strictly less than 6 and greater or equal to 5. What we can deduce that n squared is greater than 5, and n times n plus 1 is strictly less than 6. Once again, let us consider this double inequality. N squared greater than 5 and n times n plus 1 less than 6. negative, n square greater than 5, this implies that n is less than minus square root of 5, just because we have two cases, and less than the minus the square root of 5 and n greater than the square root of 5, and since n is negative, this means this, just this. The second thing we have we have n times n plus 1 less than 6. This implies that n squared plus n minus 6 is less than 0. We use here delta. Delta is equal to 1 square minus 4 times minus 6, so 25. The first solution root is minus 1 minus 5 over 2, which is equal to minus 3, and the second one is n2, which is equal to minus 1 plus 5 over 2, which is equal to 4. Negative means between the root. Negative, this means that between the roots we have minus 3, minus 1 plus 2, we have 2. We suppose that it is negative, so we start just from 0, and minus the square root of 5. The square root of 5 is here, minus the square root of 5, and which verify both of the inequalities must belongs here. So this, from this we have that n belongs to minus 3 minus the square root of 5. There is no integer between these two numbers. This means that it is impossible, we cannot find n. So in the case when n is negative, we have no solution. Okay, nice. It is nice. The second case is when the integer part is positive. We will discuss in the same way. Suppose that n is strictly greater than 0. In this case, once again, we have n plus r, which is less than n plus 1, greater than or equal to n. If we times by n, we get n squared less than or equal to n times n plus r, which is less than n squared plus n. We times this by n. This is the first inequality. The second equality, we have n plus r strictly less than 6 and greater or equal to 5. From this equation, from this system of inequalities, we can use these double inequalities. So we have n squared strictly less than 6 and n squared plus n strictly greater than 5. This equation gives us, this inequality gives us that n belongs to 0, the square root of 6. Why? Because the solution of this is minus the square root of 6 plus the square root of 6. Since n is positive, so we will get this. And from this inequality, we get n squared plus n minus 5 greater than 0. We will solve it once again. Delta equal to 1 plus 20. So the square root of delta is equal to the square root of 21. And the solutions are n1 equal to minus 1 minus the square root of 21 over 2, which is negative, and n2 equal to minus 1 plus the square root of 21 over 2, which is positive. So the solution are, you can find them, n2, here we have 0, the square root of 6, and here minus 1 plus the square root of 21 over 2. So our the solution of this system of double inequalities gives us that n must belong to this interval, which is minus 1 plus the square root of 21 over 2 and the square root of 6. Yeah. The square root of 6 is approximately 2 square root of 6 is approximately 2 dot, I think, 3, like this. Yeah, and the square root of 21 for that something, minus 1 gives us minus 1 gives us 3 something. If we divided it by 2, it gives us 1 something. So the unique integer parts which belongs to this interval is actually n equal to 2, just this one. So finally we find the value of n. So n is equal to 2. Remind that to find the value of r. So I have to, I will write it here, n equal to, so 2 times 2 plus r, strictly less than 6 and greater or equal to 5. 2 by 2, 4, so 4 we get here just 1 less than or equal to r, and 2 to 4, 6 minus 4 is equal to 2, so r is less than 1 and greater or equal to 1/2. So we will add the value of r, the extreme value of r, to n, and from this x belongs to less than or equal to 1/2 plus 2, but 1/2 plus 2, 2.5, 5 over 2. This is the less value which fits with 0, and the great value is 1. So 2 plus 1 is 3, and once again we find the same result. Thank you very much. There's still another method. I am so sorry I cannot do it for the to not let the video be very long. So thank you very much. See you next time.